Under the concept continuity, consider the question f of x equal to kx plus 1 if x is less than or equal to 5 and it is 3x minus 5 when x is greater than 5 is continuous at x equal to 5, find k. We know that when the function f of x is continuous, its LHL value and RHL values are equal. So LHL equal to RHL, that is limit x approaches 5 minus f of x must be equal to limit x approaches 5 plus f of x. That means limit x approaches 5 minus indicates LHL value, means approaching 5 from the left hand side. That means giving values less than 5. When x is less than 5, the defined function is kx plus 1. So, limit x approaches 5 minus, in place of f of x, it is kx plus 1. Similarly, limit x approaches 5 plus means approaching 5 from the right hand side. That means giving values greater than 5. When x is greater than 5, the defined function is 3x minus 5. So, limit x approaches 5 plus f of x becomes 3x minus 5. Now, if we replace the value of x as 5 in the function, we'll get 5k plus 1 equal to 3 into 5 minus 5, that is 15 minus 5, that is 10. So 5k plus 1 is 10. 5k is 10 minus 1, that is 9. So k is equal to 9 by 5. Today let us consider the concept continuity. We know that if the function f of x is continuous, then its function value at the given point and limit of the function are equal. Now consider the question f of x equal to k cos x by pi minus 2x when x is not equal to pi by 2 and f of x is 3 when x equal to pi by 2 is continuous at x equal to pi by 2. So find k. To find the value of k, let us consider the limit of the function, that is limit x tends to pi by 2 f of x must be equal to function value at the given point x equal to pi by 2, that is f of pi by 2. From the given data, f of pi by 2 is 3. On the left hand side, limit x tends to pi by 2 f of x becomes k cos x divided by pi minus 2x. Now we have to find the limit of the function. To find the limit, let us use substitution method. Take pi minus 2x as y. If we simplify this, minus 2x becomes y minus pi. So 2x becomes pi minus y. So x is equal to pi by 2 minus y by 2. If we back substitute these values in the function, we'll get limit. Earlier it was extending to pi by 2. Now it will be y tends to 0. This is because if we substitute x equal to pi by 2 in this function, we'll get y equal to 0. So limit y tends to 0, k. In place of cos x, we'll write cos of x is now pi by 2 minus y by 2 divided by pi minus 2x is considered to be y equal to 3. So limit y tends to 0, k times cos of 90 minus y by 2 becomes sin y by 2 divided by y equal to 3. And we know that limit theta tends to 0, sin theta by theta is 1. So to get that form, we need 2 in the denominator. So multiply and divide by 2 to the denominator. So now it becomes limit y tends to 0, sin y by 2 divide by y by 2. And this value will be equal to 1. So the remaining function will be k by 2 equal to 3. That becomes k equal to 6. Now let us consider one more question under continuity. F of x is equal to kx plus 1 if x is less than or equal to pi. It is cos x if x is greater than pi. Is continuous at x equal to pi. So find k. Now to find the value of k, let us use the concept. As the function f of x is continuous, its LHL value, RHL value and function value at the given point x equal to pi must be equal. So let us consider RHL value equal to function value at the given point. The given point is now x equal to pi. So function value becomes f of pi. When x is equal to pi, the defined function is kx plus 1. As x is pi, f of pi becomes k pi plus 1. And this is equal to RHL of the function. RHL means limit x approaches pi plus. Pi plus because approaching pi from the right hand side means giving values greater than pi. So when x is greater than pi, the defined function is cos x. If we substitute the limit value, x equal to pi becomes cos pi equal to k pi plus 1. But value of cos pi is minus 1. So we'll get k pi plus 1. So k pi is equal to minus 2. K is equal to minus 2 by pi.